Hey guys, and welcome back to a new video in this Kotlin Multiplatform playlist, in which you will learn how you can make HTTP requests using Ktor in Kotlin Multiplatform project. So in the shared code section, how you can use that in a composed multi-platform code base. And specifically, you will learn how you can now use Ktor client in order to make these HTTP requests for Android, iOS, and desktop, as usual in this KMP playlist. And the little app that we will build here is an app that censors insults, and all that just happens through an API. So if I go in here and I say, okay, you dick, and I click censor, then it will properly censor these insults. That API is completely free. You don't need an API key. You can just access it without any authentication, which is why I chose that one, since it's very easy to use that to experiment and learn Ktor client. As usual in this KMP playlist, you first of all need to go to kmp.jetbrains.com, make sure to enter project name, package ID, tick Android, iOS, desktop, share the UI for iOS, download this, extract the zip file and open the folder in Android Studio, so you have that composed multi-platform demo project or initial project. And I would like to ask you to also include the dependencies for Ktor that I already included here. As usual, you find the GitHub link in this video's description. So just going through these very quickly to help you understand what these are for. Ktor client core, pretty clear, I think, just the core functionality. Then we have two so-called engines for Ktor, which really drive the HTTP client behind to make the actual request. We have OKHTTP for JVM-based platforms, Android, desktop, and we have Darwin for native platforms like iOS and macOS. Content negotiation is a plugin that we can use for Ktor in order to automatically parse Kotlin data classes to and from JSON, very useful on Android. We have logging, so I will show you how we can automatically log every single request, so you can easily debug when issues happen. We have serialization, Kotlin XJSON, so just the Kotlin serialization framework we use together with this content negotiation feature. And lastly, we have client auth. That is a feature we won't use in this video, but I still want to show you roughly how that works and that this exists, since if you have an authenticated backend, this is very useful. So just make sure to paste these dependencies together with this Ktor version and this Kotlin serialization plugin. So this is for Gradle. And I also included a little bundle here, so we can just apply all these dependencies together by just referring to Ktor. All right, a little info before we get started. For 1 week, you can get 25% discount on all my premium courses, including the Kotlin Multiplatform course, for example. You just need to apply the discount code SUMMER during checkout. You can find the link down below. All right, let's get started implementing Ktor client. The first thing we need to do is we, of course, need to add these dependencies here to our build.gradle file in the compose app module. We want to scroll down here to our dependency blocks. And first of all, let's apply the common dependencies, which are the ones that I included in this bundle. So we want to add implementation libs bundles.ktor. Then that is not enough because, as I said, we have a specific engine just for JVM-based platforms, and we have an engine for native-based platforms. And because of that, we also need to add these for the corresponding platform source sets. So Android main, for example, should get the OKHTTP engine. So libs Ktor client OKHTTP. This is actually not the only engine we could use here. There are multiple Ktor engines which are all included in their documentation. So you also have specific engines just running for Windows. You have even curl could be an engine. So maybe you know the command line tool curl. Ktor also allows using that as an engine, so that this command line tool is used behind the scenes to make the actual request, or at least its functionality is used for that. But for all purposes here, just using OKHTTP and the Darwin client will be just fine. For desktop main, we are on a JVM-based platform, so we can also safely add OKHTTP there, which is a Java library. So we say libs Ktor client OKHTTP. And for the Darwin client for native platforms, we want to add another dependencies block here, which we call native main.dependencies. So this will include macOS, iOS, and all these Apple-based platforms usually, where we say libs implementation libs Ktor client Darwin. And last but not least, we want to scroll up to our plugins. Make sure to apply the Kotlin X serialization Gradle plugin, which we can do with libs plugins, Kotlin serialization, and that's it. I think we also need to reference this in our build.gradle project level file. So let's open that, duplicate the last alias here, and replace this with Kotlin serialization. Make sure to use apply false. So we just put this plugin on the class path, so our individual Gradle files like this one can find and apply this plugin in this module. Let's hit synchronize now, and then we can already get started declaring the HTTP client and how we need to create that in order to fire our requests. There we go. Gradle sync seems successful. We're gonna go to common main Kotlin, and in here, let's just create a new directory called networking or so for our network related stuff. And in here, want to create a function called create HTTP client or so. So just a function that creates this client on each individual platform. So that will just be a normal function, which we call create HTTP client. This will take in our engine, since the engine differs depending on the platform. So remember, on Android, want to use OKHTTP as the engine, on desktop as well, but on iOS, want to pass a different one, want to pass Darwin. So we want to make this variable. So we can then call this function from each individual platform's entry point. So from our Android activity later on with the Android engine, from our desktop main function with the OKHTTP engine, and in our iOS entry point with the Darwin engine. This will then return HTTP client instance. So this is really the type of class where all the magic happens in Ktor client. This is what we use to fire the actual network requests. And we can open this block of code here where we can really just return this HTTP client. We pass in our engine, and then we can open this block of code here to configure this client. And when it comes to configuring Ktor clients, and then that usually means that we want to install so-called features. I already went over that features could be content negotiation, like, hey, we want to parse JSON automatically. Or a feature could be logging, where we say, hey, please log every single request. Or it could just be authentication, which makes it easier to automatically refresh the local access token, for example, when you have some kind of OAuth authentication mechanism. And all that we can now define here in this HTTP client builder. And to install such a plugin, we say install, and then followed by the plugin name. So for example, logging. Here, make sure to use logging from Ktor client plugins. And that already suffices, but we can also open another block of code here to configure how that logger works. For example, we can say, hey, the log level is log level.all. So really every single part of the request will be logged, like the headers, the body, the responses. But if you're just fine with something else, you can also say just info or just the headers, just the body. Let's pick all here so we really see the whole request being made. And if you would have some custom logger, let's say you would use a certain logging library, then you could also make this Ktor logging plugin here, use that library. You can see the suggested code already tells you that. So we would declare a logger, make that a new Ktor logger here, and this log function would then always be invoked when Ktor would log something, and you could just delegate this call here to your logging framework. But in our case, we're completely fine with just the default behavior. Next up, let's install another feature, another plugin called content negotiation, as I said, for JSON parsing. And here we also want to define the JSON parsing library that we want to use. Here in Kotlin Multiplatform, we of course need to use a Kotlin specific JSON parsing library. So we want to use Kotlin actualization. In order to configure that, we need to add this JSON block and then say JSON is equal to a new JSON object with a JSON builder. So this comes from Kotlin actualization. And then in here, I typically like to set this ignore unknown keys to true. So what this setting will do is if the API responds with JSON fields that our client doesn't know and doesn't care about because we did not define that JSON field in our data class, for example, then normally our app would crash. But with this ignore unknown keys, we can say, okay, please don't crash and just ignore these fields. All right. And for our case, that is already enough. As I promised, I also want to quickly show you how you could set up authentication here. So you could say install auth, this one here, open the block of code, and then depending on your authentication mechanism, you could define that here. So if you would have basic authentication that comes with a specific username and password combination, you could set that up here so that Ktor always automatically intercepts these requests and make sure that your credentials are properly attached. What's very common in the real world for authentication is this bearer authentication. So this is usually OAuth, which means you have an access and a refresh token. The access token is very short-lived, maybe valid for an hour or so, and the refresh token is very long-lived, which you store locally. And that refresh token can then be used to refresh the short-lived access token when it expires. Not going into detail here, I cover that in very much detail in my Android Essentials course. Again, 25% discount right now. But in case you would have such a mechanism, you would add this bearer function here. And in there, you would first of all define a function to load the tokens, where you say, hey, this is my preferences setup. This is how you read the tokens from there, because obviously Ktor needs to know that. And then apart from that, you would have this refresh tokens function where you define how, if you have a refresh token, how you can now use this together with your specific API to get the new access token, and Ktor will then always call this refresh tokens function when it receives 401, so unauthorized response from anywhere on the endpoint. In our case, our API is not authenticated, so we can get rid of that. And that's already our function to create this client. Next up, I just want to paste a little bit of utility classes, which I don't write from scratch here because that would make this video explode and is completely unrelated, but I have separate videos about this utility result class I will paste here. So here inside of our util package, I will paste 3 classes. I quickly go over what these mean, but I will also link the videos where I explain these in detail. In the end, it's really just a result wrapper that helps us to pass both successful and error responses from HTTP client to, in the end, our UI to properly display the results. So here in util, of course, you can also just copy paste these classes from my GitHub repository as usual. We have this result class, looks super complex, but it's really just lots of generics in order to make this work for every single use case and every single app. A result can either be successful or not successful. If our result is successful, we want to attach a certain type of data. So depending on the API endpoint, the data that we want to attach here is of course different, so it's generic. And if there is an error, then we want to attach a certain type of error, which we pass here. And an error in this case with this result class is usually just an enum class that goes over certain options this error message could be. So for example, no internet connection, or serialization error, or unauthorized. These typical HTTP errors we could then attach here. You also find this here. So the error interface is really just a marker interface to only be able to pass these error types and not any type of object. And a specific type of error could then be this network error, which implements this interface, defines typical results here. We could then parse the actual error message into. We're also not going to use all of these. These are just the typical ones that I use for real projects. And then we could pass, for example, network error dot too many requests to our result error here at this point. And everything else inside of this file is really just utility to map a result to a different result, or to just have a little lambda that triggers when it is successful or not. Same for on error. But I can really just recommend this class for any type of result handling in your app, since it's quite simple, it's extendable, and it doesn't require you to add any library, since I think adding a library for something as simple as passing errors from one layer to another is a bit overkill, even though these libraries exist and do something similar as my class here. Next up, what I want to do is I want to go to our networking package, create a new class, and let's call that insult sensor client, because that's in the end what this client will be useful for. In here, we now need access to our HTTP client instance, which we will then later pass from each individual platform by using this function to create one. And in here, we're going to have a suspend function. Let's call that sensor words. And we attach an uncensored string here. And this will now give us back a result. Make sure to import the one with D and E. A result of type, well, what is our outcome? What kind of result do we expect in a successful case? In that case, we just expect another string where all of our insults are censored in the end. So we say D, so data is a string, and E, our error type, is network error, because if we are making an API call, then the type of errors that can happen here are, of course, network-related errors. And now making API calls with Ktor is actually pretty simple. Of course, on the one hand, we want to get our HTTP client instance, and then we can either use get to make a get request, we can use post to make a post request, delete to make a delete request, or put is also pretty common to a put request if we want to update a certain resource remotely. What we need here for our API is a get request, but I will also give you a quick demo on how a post request could look like, since that usually differs how a get request looks like. But for now, let's start with a get request, since that's the most simple one, where we want to pass a URL string. So here we now need to pass a URL string, which I will paste here. So this is the URL of the API that we're going to use. So this needs to be the whole URL, not just the base URL or so. Usually in a bigger project where we have multiple different URLs, I have some sort of utility function that just constructs the whole URL by just providing the encoded path. So everything that comes after the base URL. But here we only have a single endpoint, so we can just put the full URL here. And then the way this works is we can open a block of code here and configure how that request should further look like. And for us, there needs to be some way of actually passing this uncensored text we now want to censor by the API to this request. And when we make a GET request and we want to attach certain data, then that usually works with query parameters. So those are just parameters that we attach in the URL itself. I'm pretty sure you know these from your browser, where we say, okay, something like question mark text is equal to uncensored. And then we could have a parameter 2 here, which is, I don't know, 1, 2, 3, 4, 5. But that would work here. But with Ktor, we would just rather like to use the functionality Ktor provides. And we can just say parameter here, give it a text and a value. And the value will be uncensored. And then Ktor will construct exactly the same type of URL that I showed you before, but of course, in a less error-prone way, since here you could easily mistype something. And that will already be enough for our case, but you could also just attach a header here, for example, so content type JSON. If you were to maybe post a specific JSON body to indicate, hey, I'm attaching JSON data, you could attach a body here, not for GET requests, but for POST requests. So let's just switch to POST to show you how such a POST request could look like. You could say, okay, the content type would need to be application.json. You would attach a body, which would really just be, actually with set body, which would really just be any type of Kotlin data class that is marked with serializable. That is the requirement in order to automatically serialize that with our content negotiation plugin. And here you could then have any type of instance which Ktor would automatically parse to JSON. Let's see what else we do have here. This dot, you could of course attach attributes. You could have a custom URL builder, but I think, yes, I mean, Bearer auth, you could also add that individually to each request. If you don't want the auth plugin to automatically intercept every request, you could even add a cookie here. You could retry this request in certain scenarios. You could specify timeout. You can have download callback or an upload callback. So this is very useful if you maybe want to report changes about the upload progress incrementally. So maybe if you display a loading indicator or so, then you could do that. And I think that's already it. So that's how you construct HTTP requests with Ktor client. It's really not rocket science. Want to make sure to swap this out with a get again. And the result of this call will now be our response. So if we take a look in here, we get an HTTP response, which really contains all the response data, like the status code, the potential body that the API responded with. What's just important here for us is that we take this call and wrap it into a try and catch block, since there are exceptions that can happen. On the one hand, that is an unresolved address exception, which is not only called when the client can't find the API and URL that we want to talk to, but also if there is no internet connection. So here, we could return a result.error with network error.no internet. Another type of exception that could happen is a serialization exception, where we then want to return result error, network error, serialization. And in here, we can just paste the initial GET request. Awesome. If the code reached this point, then we know that we at least get a response back from the API. So what I want to do is, or what I typically do is, I return when our response.status.value, so the actual integer code of the response status, whether it's 200 OK, 401 for unauthorized, 409 for conflict or so, we can now check for which specific error happened there and then parse it to the corresponding result. If the response status is in the range 200 to 299, because every single HTTP status code that starts with a 2 indicates successful, then we want to parse that, or want to read the result from the response. Then we want to read the result from the response, which we get from the API. And the way the JSON response looks like from this specific API is just, can I show you this here? It's just something like this. We have our result JSON, and then here we have u XYZ, and we close our JSON body. This is how the response body looks like. So what we now need to do is we need to define a Kotlin data class annotated with serializable, which has one field, a string field called result. That's what we can do in our networking package. And we also call these types of classes DTOs, data transfer objects. So just objects we transfer over the network. And then here we can call this, I don't know, censored text, for example. Make that a data class, annotated with serializable, as I said. And then we give this exactly the same name as coming from the API, called result, and that's a string. And then we can say, okay, we have the censored text, which is equal to our response.body. And here we now specify the type of body we expect, which is of type censored text. And once we have that, we can say, okay, we return a result.success, and we attach our sensor text, that result, so the actual sensor text, to our successful result, and the result will then get passed to our UI, where we can check, okay, was that successful? Then please show the sensor text, and if there was a specific network error, then show the network error. We're not done yet here. Instead, we also want to parse specific error codes that could happen. So if you were to have an authenticated API endpoint, you would check for 401. Return here, result error unauthorized. If there is, I don't know, 409, then it's conflict. If there is 408, then it's request timeout. If it is 413, it is payload too large, so you are trying to upload a file that the server does not accept. And that way you can just specify all those individual HTTP error codes that you want to care about in your app, that you want to display a specific error message for. So I typically do it like this. I will leave it here. I know we have a few more errors, but I don't think these errors can happen here with our single endpoint in the first place, but just that you also learn how you can pass these errors in a more realistic environment with just more complex endpoints where the range of potential errors is just bigger. One last type of error that I always include is 500 to 599. So this means there is a server error, something went wrong in the server. This is not a fault of the client, but still you need to handle that in some sense, displays like, oops, something went wrong or so the user knows that something went wrong. Let's just say, okay, else we have an unknown error. So if there's any other specific error type we don't explicitly handle here, we attach unknown. Let's remove our JSON. And now that we have our client, we can use this in our UI. And I won't apply any proper software architecture here, since I really just want to focus on the Ktor functionality, and I think I have plenty of videos about how we properly structure architectures of apps. But here for this demo, I will really just use this client directly in the UI, which normally I wouldn't do. Normally I would add a view model where I update some kind of state, but let's use this directly in the UI, so we don't have to set up a view model, potentially a DI framework and all that stuff that goes with it. Let's go to app KT, which is our UI. Here we can remove the show content state, which is there by default. Our column can stay. We override the modifier here. Modifier fillmax width, no, but fillmax size, yes. We center it horizontally, and we also want to center it vertically. So you want to say arrangement spaced by 16 dp. So we have 16 dp of space between each item, and I still want to center these. So we say alignment center vertically, of course. And then inside that column, we definitely need a button in order to fire our request. We can call this sensor. And down here, let's get rid of this animated visibility. We don't need that. Let's first of all declare our local state. So those values that can possibly change in our UI. On the one hand, that is our sensor text. By remember, mutable state of, which is initially null, because initially there is no sensor text since we need to wait for the result from the API. This is a nullable string. Then we do have our uncensored text, which is the state for the text we have in our text field. So mutable state of empty string by default. We have an isLoading state by remember, where we say, okay, that's initially false, and we will just show a little progress indicator on our button when the API call is firing. And lastly, we have an error message state. By remember, mutable state of, and then initially the error message is also null, but it could be any type of network error now. And what we need, since we need to execute our suspend function here from the sensor client, is a coroutine scope. We can get a coroutine scope with val scope. Remember coroutine scope inside of a composition here to get one that is just aware of the composition and will be cancelled as soon as, in this case, the app composable leaves it, which won't happen. So this is kind of a UI-wide coroutine scope in this case. All right, so what we now need in this column is on the one hand a text field, which lets us input our uncensored text. So text field actually, where the value is our uncensored text. And on value change, so when we type something, then we set the uncensored text to the new changed value. We can give this a modifier of, I don't know, modifier padding, let's say horizontal padding of 16 dp, and then we say fillmax width. And we can also possibly give this a placeholder text where we say we have a text that says, I don't know, uncensored text or so. Below this text field, we then want to have the button. When we click the button, we want to fire the API call. Let's wait with this for now, since that's the most complex part here. Just inside the button, we want to make the content dependent on our isLoading state. If we are loading, we want to show a circular progress indicator where we say, okay, we give it a little bit of a smaller size than the default size, maybe 15 dp. We might want to give it a little bit of a smaller stroke width of 1 dp and a color of, let's say, white. If we're not loading, we show our text instead. And what we need below this button is, on the one hand, a text composable for our sensor text when we get the result from the API, where we say, okay, sensor text !.let, so we make a null check. And if that's not null, we just show the text. And below that, in case the error message is not null, we show a text with it. Let's just print the name of the enum. Normally, you would, of course, go through the specific enum type and map that to a human-readable error message here. But I think you get the idea. Let's also make sure that the color is color.red in this case. Okay, that is our UI tree. The last thing that's now missing is that we also update these 3 states here when we make our API call. That happens here in our button on click. We can launch a coroutine scope with scope.launch. Initially, set isLoading to true. And the error message to null, that's actually also correct. And then we can use our client, which we don't have yet here. We need to pass our insult sensor client here. Client, insult sensor client, which we again need to construct on each individual platform. So we pass this from the outside as usual for these kinds of things. And down here, we can then say client.sensorWords, pass in our current state of the uncensored text. If that's successful, we can say on success. And if there is an error, we can say on error. If it's successful, we do get the result, so the sensor text here in the Lambda, where we can just say, okay, sensor text is equal to it. And if there is an error, then we can say our error message is equal to it, which is a network error. After these calls, we can set isLoading back to false. And I think that should be everything. Just again, the little disclaimer, I don't really do this in real project. You don't want to execute such data-related calls in a UI coroutine scope, since the scope will be cancelled when the UI is cleared, which on Android could be due to a screen rotation, for example. So you would fire the API call, the user would rotate the device during that call, and the call would be cancelled since the scope is cancelled. It's really just a demo to not need this whole architectural setup here in this video. But if you're interested in how you can really structure a solid architecture from the ground up, I have plenty of videos. I have my premium courses, especially the Android Essentials one. So feel free to check that, of course. The last thing that's missing is that we construct this client on each individual platform and then properly pass it to this application entry point. Let's start with Android. Go inside of Android main, Kotlin, open our package and main activity, which is the Android, the entry point for Android apps. We can get rid of the preview here. Whoops. And in here, we now need to pass our client, which I'll just construct with remember here. And we say, okay, that's an insult sensor client. And we pass in our create HTTP client function, which now takes an engine specific to Android. On an Android, as I said, I want to use the OKHTTP engine. So we pass this here, OKHTTP from Ktor client engine OKHTTP, and we call .create. We can then copy this line, or actually this whole remember block, since we need the same one on desktop and iOS as well. So let's go to desktop main, open main KT, and here we can paste this remember function, give this a name of client so it's a bit more clear. Here we also want to create the OKHTTP client. That's fine on desktop, and on iOS we're not fine with that. Here in the main view controller, here we can say client is equal to remember. Just for the OKHTTP client, we need to replace this with Darwin, so our iOS specific client. And I think, no, that's not it yet. Just one little thing we need for Android specifically is inside our manifest, we need to declare that we are using internet. So we need to say users permission internet. That's just a thing exclusive to Android. I love to forget that when building this, but I am pretty proud that I didn't right now. We can close this again, and I think we should just give this a shot. Execute this here on my device. First of all, the Android version, open this here and wait for Gradle to finish building. There we go. That is looking pretty good. In here, let's again use udic and we click sensor. We do see our progress indicator, and yes, we got the result. We can also open Logcat here and look for the logs, since Ktor gives you these, or not. Where are our logs? What if we fire this again? Is this the right one? There is some kind of OKHTTP issue, but that is, well, yeah, that isn't from right now. I think there's just an issue with the Logcat right now. Do we get logs now? I don't know. Let's try this again. we enter something. We can also just enter test, which won't be censored. For some reason, it doesn't really print this. Let's first of all try this on the other platforms, because there we also have a specific log section. If it displays there, then it's really just a logcat issue. And if not, then I will also need to quickly look into that. But you can see that seems to work on Android. Let's tick iOS app, launch this. There we go. Our app is apparently installing and opening. Here we have it, our text field where we say, okay, test, click censor, and yes, we also get the result here. And we also see the logs here. You can see we made the request here to this endpoint. These were our headers. We don't have a body, which would be there for post requests if you would attach a JSON body, for example. And here is our response. So really just seemed to be an issue with the logcat. Here for the response, there is of course a body, which you can also see here. This logging feature is really just awesome for debugging in case some of your requests don't work. Lastly, let's check this for desktop, of course. In desktop main, run this here. It will fail the first attempt. We can minimize this and now run it from Gradle. Just like in the last videos, gradlew.run, and then another window should open up. Here we go. Here is our desktop project, desktop app, where we can also enter something, censor that, and then it will display that in a censored way. I will leave it completely up to you to experiment with more serious insults here. I don't want to lose my monetization status here for this video, but you can believe me, I already did that behind the scenes, and it also works for other types of insults. Awesome. As I said, 25% off on all my courses, including the KMP one. Check it out. And other than that, thanks so much for watching. I will see you back in the next video. Have an amazing rest of your week. Bye-bye.